Prisoner's dilemma. There are two convicts who are caught up in a crime. Both of them are taken to two different chambers and they're being interrogated. Both of these convicts, they have two choices which are open to them. Either they can remain silent or they can betray the other prisoner. That is, either they can cooperate or they can defect. And the assumption is, of course, that both of these prisoners, they have no loyalty to each other, and definitely there is no reward outside the game. So supposedly, if A remains silent, that is, there are two prisoners, A and B, and if A remains silent and B also remains silent, then both of them gets 1 year in jail. 1-1. Well, if A remains silent and B betrays, then A will get 3 years in jail and B will be freed. Ideally, I should put minus here just to show the negative payoffs. And if A betrays, he will be freed, but and B remains silent, so he will be given 3 years in jail. While if both of them betrayed, then both of them are going to get 2 years in jail. Now, if A has to remain silent, the best strategy for B is to choose from either this or this. So the best strategy is to betray. If A has to betray, the best strategy for B has to choose from either -3 or -2. So the best strategy is to betray. Well, looking at it from B's angle, if B has to remain silent, the best strategy of A has to choose from either -1 or 0. So the best strategy is to betray. While if B has to B has to betray, then the best strategy for A has to choose from -3 or -2. So A should also betray. So what we are seeing is that equilibrium is converging towards betray. Okay, well, if both of them would have remained silent, it would have been a better equilibrium. They could have actually been sentenced for a lesser term, but both of them betrayed because both of them acted selfishly. Okay, now we'll see to other versions of Prisoner's Dilemma also in the later recordings.